Welcome to The Explainer. Today, we're going to suit up and dive into the fascinating world of wearable robotics. These are devices designed not to replace our abilities, but to give them a serious boost. So, let's get right into it.
Let's start with a problem, and a pretty huge one at that. In the European Union alone, a staggering 64% of employees have jobs that require them to lift or move heavy loads. Now, this isn't just tough work, it's a leading cause of work-related musculoskeletal disorders. We're talking about a massive health and economic issue.
And that really brings us to the big question, doesn't it? What if technology could step in and help share that load? This is where the hero of our story comes in, the exoskeleton, a piece of tech that promises to work with us, to literally help shoulder the burden.
So what exactly is this wearable solution we're talking about? Well, it's a concept that is moving incredibly fast, right out of the pages of science fiction and onto the factory floor.
Okay, first, it's really important to understand what an exoskeleton is and what it isn't. This is not a bionic prosthesis that replaces one of your limbs. No, an exoskeleton is a wearable device that works in sync with your body to assist a movement. Just think of it as a powered partner for your own muscles.
Now, these devices come in two main flavors. On one hand, you have passive exoskeletons. These are purely mechanical. They cleverly use things like springs to store energy when you do one movement, like, say, bending down, and then they release that energy to help you with the next movement, like standing back up. And then you've got the active ones. These are the real powerhouses, using motors and actuators to give you a serious power boost.
Which, of course, brings us to the core question for those active exoskeletons. How on earth does a machine know what you want to do and when you actually need its help? Well, the answer lies in this really simple but incredibly sophisticated loop: sense, think, and act.
First up, sense. The device basically has to be a mind reader. It needs to figure out your intention to move, sometimes even before you fully started the action yourself.
So how does it do that? With an array of some pretty incredible sensors. For instance, you've got surface electromyography sensors, or SEMG for short, that can actually read the faint electrical signals your brain sends to your muscles. Then there are inertial measurement units, or IMUs, that track the motion and orientation of your limbs. And you've also got force sensors that measure the physical interaction between you and the machine.
Okay, but all that raw data is just noise until you can make sense of it. That's where the think stage comes in. There's an onboard computer that acts as the brain, interpreting all those sensor signals in real time.
And listen, this isn't some simple bit of code. We are talking about sophisticated algorithms, often using machine learning and AI to process a storm of data. They take those faint electrical signals from your muscles and the tiny shifts in your posture, and they translate all of it into one clear prediction. Okay, the user's about to lift this box.
And once that intention is crystal clear, the system has to do something about it. It has to act. It's got to deliver that physical assistance at precisely the right moment so that it feels natural and is actually effective.
This is the job of the actuators, the muscle of the machine. These can be powerful DC motors or more advanced series elastic actuators that actually mimic the springiness of our own tendons, or even complex cable-driven systems. Whatever they are, their job is to apply torque to the exoskeleton's joints, giving you that superhuman feeling boost.
The technology is obviously impressive, but let's get to the real bottom line here. Does it actually work? It's time to hand out the exoskeleton report card.
So let's start with the objective grade, the hard data. And the results here are really promising. Study after study confirms that wearing an exoskeleton significantly cuts down on the physical strain on your body.
I mean, just take a look at this one study. When workers used a passive back support exoskeleton for assembly tasks, researchers measured a 35 to 38% reduction in muscle activity in the lower back. That's not a tiny improvement, that's a massive decrease in the load on one of the most vulnerable parts of the body.
But, objective data is only half the story. A tool is only useful if people are actually willing to use it. So, how do these devices feel to the people wearing them every day? What's the subjective grade?
So, how do users actually rate the experience? Well, on the system usability scale, which is a standard way of measuring this stuff, one rehabilitation exoskeleton scored an 80.7 out of 100. Now, to put that in perspective for you, anything above a 68 is considered good. And 80.7, that's officially rated as excellent.
But it's not all perfect.
it's time for a little reality check. The path from a controlled lab to widespread everyday use is, well, it's filled with some very practical challenges. User feedback really brings things back down to earth. I mean, listen to this quote from one study. It highlights a huge hurdle. It's one thing to wear a device for a 20-minute test in a lab. It's another thing entirely to wear it for an 8-hour shift. Simple things like heat buildup can become absolute deal breakers.
And this complexity reveals some really important trade-offs. For example, one study confirmed a back support exoskeleton worked exactly as planned. It decreased back muscle activity. Great. But it also found an unintended side effect, a slight increase in the vertical force on the user's knee joints. You see, solving one problem can sometimes just shift the strain somewhere else.
So, we have these amazing results on one hand and some very real challenges on the other. So where do we go from here? What's on the road ahead for this technology?
Well, the path to getting these things seamlessly integrated into our lives involves a few key steps. First, getting out of the lab and into large-scale field studies to test long-term performance. Second, developing smarter AI. Get this, some systems can now learn your unique walking pattern in just 80 steps. And third, we need to establish new ergonomic standards to properly measure both the benefits and the risks.
Because at the end of the day, the ultimate goal here is to perfect this human-robot cooperation. The real magic happens when you can minimize the interaction force between the person and the machine to make the assistant so smooth, so intuitive, that the exoskeleton feels less like a tool you're wearing and more like a natural part of your own body.
And this brings us to our final thought. As these devices get lighter, smarter, and more integrated into our work and our lives, we have to ask a pretty fundamental question about the future. Is the future of human potential actually a partnership with machines? It seems like the answer might just be a powerful, cooperative yes.